Hello, everyone. Thank you for coming to story time at PyCascades this year. You've heard it hinted earlier in Piper's talk, and then also in the introspection talk about the certain Dunders you can make. So I thought I'd read this book by Dunder Seuss to help us learn a little bit. Oh, come on. Wrong one. All right, there is an about the author here. Josh Buchanan, aka Dunder Seuss, has wrote no books so far, has been on a single podcast and done exactly one talk before he decided to write this book. He is a developer productivity engineer by day, a maintainer of the Pants Build open source build system by day, and sometimes participates in open source projects, Python community discussions, and conference speaking, also by day. He's a lover of getting to know enough Python to make expressible, readable, and intuitive code. He wrote this book to teach others the power and magic that you can bring to your objects to make them expressive, readable, and intuitive. And then also this year, there is an AI addendum. Although Midjourney was used to create the whimsical graphical art, absolutely no AI of any kind of text generation was used for the content. The author feels that would ruin the artistic value of the book. It is dedicated for Devin, Dottie, and Teddy with love. Let's begin. Congratulations, today is your day. You will soon learn you some magic the good and proper way. You've chosen a wise way to spend your precious time by learning from a crazy loon going on in rhyme about how a list of methods that are nicknamed the Dunders and how you'll use them to code great wonders. They start with 2 underscores and end with 2 more, thus Dunder, which is short for double underscore. The runtime of Python calls them in many situations, allowing your objects many customizations. You'll learn all about how to emulate a container and iterators and numbers from a great explainer, comparisons, callables, and descriptors too, and how to make attributes appear out of the blue. You'll learn some new names, and I know you'll learn many, at least 1 if not 2, maybe even up to 20. By the end you'll know magic galore, you'll be so full of magic you'll yell, please sir, no more. So with great skillful skill and with lots of caffeine, let's start off your learning with a method you've seen. Let's pretend you're new to Python just for a minute, then you'll learn the very first magic, Dunder init. It's almost every object's initializer, allowing you to be an attribute organizer, adding new attributes to your fresh new object, the most common magic I truly do suspect. But where did self come from? You'll soon start to wonder. Then you'll learn that it's created by just another Dunder, one that constructs the blank object given to you, and its name, as you'll soon find, is Dunder new. It's a special static method you'll maybe define in your class, which returns some object, then onward it's passed. To whom it turns out depends on the returned object's type. If it's an instance of your class, including a possible subtype, it goes to Dunder init, you'll hear from the scholar. But otherwise, he'll say, it's back to the caller. You'll see this in action, and it'll be a little cleary by looking for its use in the standard library. Pathlib.path uses this method to help it perform, constructing an object specific to your platform. The type, as you'll find, has defined Dunder new to return a subclass's instance specific to you. Now, with great careful care and with great tactful tact, you'll see that using it is a great balancing act. A magic with the power to create objects that are new is something to avoid misuse of too. And speaking of balance, the opposite of Dunder new is not oft employed. Dunder del is called right before your object is destroyed. You'll use it to release resources you've acquired, but only if you want. Its definition isn't required. But if you do write it, heed this warning as well. You must call your supers Dunder del. The next set of magics involve conjuring illusions of attributes, giving your callers delusions that your object has more or less than it does. Why? Friendly interfaces is the because. First on your journey through attribute emulation, Dunder getAttr is the proper incantation. You'll type it out with a flick and a twist, and you'll synthesize attributes that don't exist. It's called when default attribute access fails. The attribute just simply wasn't in the details. You'll get a chance to pretend it existed. However, on your object, the attribute isn't persisted. Now, if you wish to pretend you don't recognize this name, raise attribute error emulates that all the same. It has an alter ego named Dunder getAttribute, you'll see, which is called for all access unconditionally. It gets called for names both existing and not. But beware, infinite recursion is easily got if you happen to type out self dot. So remember, when you need to access attributes inside of your thing, you won't use self dot, give your super a ring. To juxtapose get, Dunder set attr is how attribute setting your classes allow. Again, by default, the attribute isn't persisted. You get to choose whether it becomes listed. This is also called for all attributes without any condition, whether it exists or not without your permission. The last of the attr methods you'll maybe leave off. Define Dunder del attr, and people might scoff. As you'll probably guess, it's good for emulation of the removal of a name from your object's formation. And just like Dunder set attrs unfortunate asymmetry, it gets called for all names unconditionally. You'll then find out soon enough that when it comes to illusory stuff, attribute names is just where it starts. There's more you'll learn, another 2 parts. Yes, like all good things, these magics come in 3, in more ways than 1, as you can see. The first way is the trio of names, get, set, and del, and how they're used for other illusions as well. The second in our trio of trios I'll teach to you now. These methods are so powerful you'll see how an attribute gets to customize itself instead of sitting static on some other object's shelf. Descriptors is the name given to this technique of attributes themselves using doublespeak. First, these things work as attributes of a class. You'll see Django and SQL Alchemy use this en masse. The descriptor is the attribute, and it gets a say on how it gets gotted and setted and deleted, per se. Dunder get is the first of these spells you'll want to perfect, conjuring values for attributes based on the owner's object, or sometimes the class, as callers sometimes will do, so your Dunder get should support that too. And uses of descriptors you'll find sooner, not later. They're used for several built-in decorators. Static method, class method, and property all use this technique to customize your attributes for you. Just like Dunder get attr, Dunder get has 2 brothers. Dunder set and delete are the others. They act just like Dunder get and proxying a call and can do anything they want, both big and small. You've maybe have wondered or even had a theory how SQL ORMs quickly fire off a query. When you access certain attributes in your class you set, the column descriptor is leveraging Dunder get to run a SQL query using the instance's database ID and return to you the value, and maybe cache it, you see. You'll see Dunder set gets called for attribute assignment. A SQL update is likely used for new value enshrinement. Lastly, Dunder delete when an attribute is told to go bye-bye. A SQL delete you'll likely see flyby. There's one more method that plays in this game, and it's a method that goes by Dunder set name. Our trio is really 4. What a shame. At the end of your class definition, you see, for all of the class attributes that be, if they define a Dunder set name, the attribute's name, Python will disclaim. And thus, the attribute shell game now comes to a close. The illusions of attributes we have now exposed. The last trio of trios you'll learn from your trainer is emulating items inside a container. You'll see this time our trio suffix is item to help quack like containers with things inside them. They are given the key, and in one case the value. Implementing container semantics are then up to you. Dunder get item has different behaviors on the radar depending on the type of container that you are. Your sequich types, which quack like a tuple or list, will accept keys as integers and slice objects. Negative int support is something you can choose to allow or not. It's simply up to you. If a value provided is outside of your bounds, an index error, your code should resound. Otherwise, if your container has a mapping background, you'll raise key error if the key isn't found. And in every case, if you reject the key's type, raise type error, you'll then want to gripe. You'll learn too, those rules still hold true for the other methods too. And as far as containers go, there are a few more Dunders you'll want to define lest you commit several blunders. So although our trio of trios may have come to a close, you'll want to learn the other container methods, I suppose. A quick one that you'll want to define is Dunder len, which helps Python divine the length of your container so when people call len, Python can return the number back to them. The second one is Dunder iter, which should return an iterator over the objects that live inside your object container. Unless it's a mapping, then what your caller sees is simply all of the mapping's keys. There's also this trivia, a bit of Python fun. If your container isn't iterable, set Dunder iter to none. Now third on our extras is named Dunder contains to test if an object your container maintains, although technically you don't have to define it, Python won't be bitter. Instead, it'll test membership first using Dunder iter, going over every possible object that your object can contain and asking if any of those objects is equal or the same. But if you also don't define a Dunder iter, Dunder get item is called and repeatedly tested. using incrementing indexes from 0 until then it gets an index error exception or equal same object, so it's best to define it so you have control of just how the object membership test will enroll. And if for optional methods you'll have started to thirst, another one available is Dunder reversed. It returns an iterator for doing backwards iteration, but you'll only define it if you beat the default computation that Python uses, combining Dunder get item and Dunder len, indexing from backwards to 0, and then there's one more optional method if you subclass Dunder dict. Dunder missing can be defined so that Dunder get item can predict what value to use if the key in your mapping isn't there yet. It's how collections.defaultDict or counter with care support operations on items conjured out of thin air. Python just returns to your caller the value itself, so if you want to, don't forget to store it in yourself. You'll find that you're done. You've mastered container emulation, but next set of magics form quite the combination. See, you briefly dipped your toe into a few operators. However, you'll find the list of ops to support is oh so much greater. You'll think about plus and minus and start figuring that the list of operators is biggering and biggering. So, on to the mathematic ones you can define. Dunder add lets you support the plus sign. When your object is on the left with whatever's on the right, you return the added value, except when you might reject the operation because you don't know what to do, and instead return the not implemented singleton value. Such is the case if you don't recognize the type of whatever it is of the thing on the right. Then, Dunder sub for subtraction, Dunder mul for times, Dunder true div or floor div, depending on the kind of division you want, true or integer respectively, using 1 / or 2 for division collectively. And speaking of operations that come in pairs, modulo arithmetic is a double Dunder affair, with Dunder mod for modular support and Dunder div mod to support the div mod built in. The last pairs of magic method gifts is Dunder L and R shift. Then next up is Dunder pow for to the power of support, whose operators 2 asterisks side by side for short. And then, although the list was already so long, 3 more Dunder methods will come along, Dunder and zor and or. Oh, come now, don't gripe. They're how you support ampersand, caret, and pipe. And then when your object supports the @ symbol, the method you'll want is named Dunder matmul, and then that was it. There won't be more later. 14 methods for mathematic operators. Oh, and I forgot the last one on the list there. There you go. Unless you think that isn't enough. Here, let's take a poll. Is there other number stuff we need to define? If yes, raise your hand. I see. I suppose our list should expand. You'll maybe be asking yourself, oh teacher, how come? You'll ask yourself where these new methods are from, and how come my methods sometimes return not implemented if to my caller a type error is presented. And so our list of methods then expands to support the same thing with swapped operands, but only if the result is not implemented, and if 2 different types are presented. Python tries again, but this time with an R at the front of the name. It's not that bizarre, and calls this other method on the thing on the right. Let's see an example to bring how this works to light. Let's say that someone subtracts from a list your foo. Well, list doesn't know what the heck to do, so it's Dunder R sub, then returns not implemented. Then the runtime continues on as documented, noticing that list and foo are 2 different classes, and calls foo's Dunder R sub, and it passes the list object on which we've acted, so foo can say how it should be subtracted. Now, you'll have to remember to be dexterous and deft, and never mix up a right op with a left. When in an R method, you're the one on the right. Getting this correct will make you seem bright. How about another poll? Hey, that last one was fun. Who thinks our mathematic operator list is done? For the record, there's almost no hands. Well, me neither. As it turns out, you'll soon enough see all but one of these methods support requires 3 Dunders at most for each of these things. What joy to us supporting math operators brings. So what sets these apart? So you'll groan and you'll grunt. These last set of 13 has an I on the front. They're meant to support doing the math in place, mutating the object given in the left space. For instance, plus equals uses Dunder I add, completing the addition support triad. However, these methods you can actually omit. They're there to help avoid copies a bit. If one of the methods your type is lacking, then x equals x plus y will be the fallbacking. And if you kept watch, you might think I left one for later, but no, Dunder div mod has no in-place operator. Now, oh baby, oh, how the operator list will still grow, regardless of lengthy class definitions, you know. You'll complain, and you'll curse, and you might even swear, but you still need to learn the Dunders to compare. The names of these methods really aren't at all surprising. The brevity of each name is what's really quite appetizing, using only 2 letters to present each operator for operations equality lesser and greater. And exactly like the methods that I just reported, they return not implemented if the comparison isn't supported. And if you want Dunder any, you can simply omit. Dunder EQ is defined. If defined, will be tested a bit, and the return is inverted unless not implemented. However, this time there's no crazy switcheroo. In this case, a type error is raised unto you. And in the case the comparison is okay, a true or false value return is the way. Or anything truthy or falsy is okay. It's turned into a Boolean the Pythonic way. Oh wait, forgive me. That's actually a new Dunder. Oh, magics on magics, isn't Python a wonder? If you want to make your object seem falsy or true, you'll have to define Dunder bool too. Unless perhaps you define Dunder len, an empty container is falsy then. Last one's on our list, and yes, it's still growing. Brevity at this point, we are simply foregoing. You'll only need 4 more, so no need to get wary to support the operators unary. Dunder neg, pause, abs, and invert you'll learn for minus, plus, abs, and tilde x in turn. And that's it. You'll think our list is complete. And you're right, I think. Now isn't that neat? 55-ish methods to support the operators. No list of magics in one section is greater. Actually, that's not true, as you'll find out. Emulating a number gets to tout the longest list of required magic capitulators, because in addition to most of those operators, there's even more you'll want to support, you'll see. Numbers, I guess, just have a lot of flexibility. From mathematics to the list, then adds on 4, Dunder round, trunk, seal, and floor. What these methods each do, you'll notice is visible, truncating the value into an integral. Then from a number, you'll have several excursions if your object supports any of several conversions. Dunder complex, int, float, bytes, and stir are magics which Python will look and refer to make the type conversion occur. And speaking of strings, they've got special magic too. Dunder repr and format will be waiting for you. Dunder repr returning the official string representation of an object. An executable string of your object is what callers expect. And for Dunder format, you'll choose exactly how to trek through formatting your object based on the spec. The other magics all come in small lists, and then in this tome, some of them won't exist, like the 11 methods for copying and or pickling, yet here are some more for you coming in at a trickling. If you want your object to quack like a function, Dunder call is the callable magic junction. Or maybe you'll quack perhaps like an iterator. Dunder next is the method for that imitator, returning the next value, or the special terminator, which goes by the name of stop iteration. You'll raise it when there's no more values in your formation. And if you want something that supports use with, Dunder enter and exit says the word Smith. The former is issued right before the inner scope. Return self is usually the trope. The latter is called when the inner scope is done, whether it finished or ran into an exception. This method has power in multiple ways. It can release acquired resources always, but it also gets a chance to suppress an exception. Return true to complete that interception. And then there are some which feels kind of wacky. Defining them sometimes feels a bit tacky. Dunder init some class, if defining it you have dared. Every time a subclass of yours is declared, it receives that subclass as quick as molasses and was added to wean off some use of metaclasses. And speaking of metaclasses, there's Dunder prepare, but on second thought, you'll not want to go there. The last of the magics on this magical list of treks are for hooks into instance and subclass checks. Yeah, that's right. The objects you write actually gets a say on the answer of is instance and is subclass, yay or nay. However, these are looked up on the type of your class. Oh, metaclasses again. How about we pass? And actually that's it. No more magic I'll disclose. Your journey you've journeyed now comes to a close. To know most of them, including the ones this talk doesn't entail, read https://docs.python.org/3/reference/datamodel.html. Or just ask Google for the URL. Since most of the magics that page does detail. Now, since your magic is waiting, And as you go on your way, remember the things I remembered to you today and write all of your code the good Pythonic way. The end.